Hello friends, welcome to Study Algorithms. And today we would learn how to go about comparing two different algorithms. In your everyday life, we tend to compare two similar objects. For example, if you're going out to buy a new mobile phone, you would have certain criteria in your mind using which you would be comparing both the two devices. And then you would determine, okay, this is a better one. Same is the case with algorithms. And in this video, we would be looking into exactly that. First, I would explain you why comparison of two algorithms is necessary. Then, we would determine what factors determine the quality of an algorithm. I will then show you actual examples how these factors make a difference. By the end of this video, I hope you will have a better understanding at what key points you must look while comparing two algorithms. So, without further ado, let's start. Let us say you're deciding to buy a new mobile phone. You would have certain criteria in your mind. Some people would want a better RAM, whereas some people would go for a bigger display. So, over here, the display size and the RAM capacity are two factors based upon which you are making a decision. Similarly, let us remove the example of mobile phones. Now I'm going out to buy a car for myself. When I'm thinking about a car, screen size and RAMs won't matter, right? For a car, one might think that, okay, I want a luxurious car. Or one might say that, okay, I want a bigger car, such an SUV, or a small car, which would be a sports car. So, in case of a car, your factors are very different. Thus, depending upon the product, our criteria also changes. Same is the case with algorithms. The next question you should be asking is, okay, so how can I go about comparing two algorithms? Here are two algorithms on your screen. Now, you don't have a specification sheet that says, okay, this algorithm is better due to these qualities, and this algorithm is better due to these qualities. So what do? The closest you can say that, okay, this algorithm looks shorter to me, and hence probably this is a better one among the two. But my dear friend, in computer programming, actually, longer algorithms might be more efficient as they handle all the edge cases and improve your speed. Hold on to that thought for a while. This should give you a hint at what is an important factor while determining the quality of an algorithm. Yes, it is time. Computers were invented to reduce the human effort and to do our tasks more efficiently and in a more fast manner. So, naturally, an algorithm that will run faster would be considered to be a better one. Actually, let me show you what do I mean by that. To start off, I have created a program that generates up to 10 million integers. So, this is the code. So, let me just quickly generate this file that has just 10 million integers. So, this file got successfully written. We can verify its contents over here. So, you see the file integers.txt has been created. Now, to have a look, it starts from 0 and goes all the way up till 10 million, right? So what we would be doing is we would try to find an integer from this file. And to find this integer, I have written two algorithms. So algorithm 1 is just a linear search where we search a number using linear search from starting till the end. Whereas algorithm 2 is a binary search algorithm which is supposedly more faster than a linear search. What I would do is, if you look towards the window on your right, I have written a main program where I first use algorithm 1 and try to find the number 5 million in this. But before finding, I have a variable start that records the time and I have a variable finish that records the end time. So once this function returns me a result, I should know the time elapsed. And similarly for algorithm 2, I would again use the same file to find the number 5 million, but this time I would be using algorithm 2, which is binary search. And once again, we would try to see what is the time taken by both of these methods. So in our file, we have the numbers from 0 up till 10 million. That means 5 million should be in there. Now, if I run this file, what happens? So algorithm 1 found the number and it took almost 3 million nanoseconds, whereas algorithm 2 just completed the same result in 4000 nanoseconds. That is a drastic improvement, and you can see that algorithm number 2 is way much faster than algorithm number 1. Let me try to twist this problem a little bit, and let me remove one of the numbers from this file. So this file has all the integers. So what if I remove the number 6 from this? Now this number is removed, and I would try to look up the number 6 in both of these algorithms. Let us see how much time it takes now. Yeah, again. So even when a number is not found, algorithm 1 took almost 6 million seconds just to say that the number did not exist. Whereas algorithm 2 was able to determine in just 5000 nanoseconds that a number was not in the array. So you can see that using the binary search algorithm is way much faster than just using a linear search algorithm. These differences may be in nanoseconds, and with the current machines like quad core and 8 core systems, you might not even feel the difference. But when you're writing bigger and bigger code for distributed systems and for very large platforms, you certainly want a faster code. Think about it. You're searching for a channel on a TV. You push some number on a remote, and then the TV takes like 3 seconds to actually show you that channel. You wouldn't like that happening, right? So, at this point, it is safe to say that time is a very important criteria while determining the quality of an algorithm. But time is not the only thing that describes the quality. Have you observed that often while browsing on the internet and looking at all your favorite websites, if you have a lot of tabs open, let's say your browser is open and you have 70 tabs open, you would notice that your system starts to lag a little. Why is that so? That is because that browser has taken up all the free memory available to you. Certainly, if you put more RAM in your system, your computer will be able to handle that load. Or if you go on and close all your unused tabs, then again, voila, your computer is running fast again. Why did I go on too fast? Just a couple of minutes ago, we proved that a faster algorithm is a better one. So, if your program is consuming less memory, then in turn it can be faster also. Let me show you with one more example. What do I mean by the memory consumed by an algorithm? Let us say you are given with these two sorted linked lists, and your task is to merge these two sorted linked lists into a single list that is sorted in itself. Now, how do you go about doing that? We would be looking at two algorithms and then we would be comparing them. Now, each of these lists would be occupying some space in your memory, right? To make things easy, let us assume that one node of this linked list takes up a total space of 10 KB. So, in this case, list 1 has 5 nodes. It means that the total space taken by list 1 would be 5 into 10 equals to 50 KB. And list 2 has 3 nodes, so the total space taken by list 2 would be 3 into 10 equals to 30 KB. The first list has a size of 5 and the second list has a size of 3. When you would be merging these two lists, you know that the size of the resultant list would be 8. So, one way to solve this problem would be I can create a new list that has a size of 8. Once I have created this new list, what I can do is I can go over each of the elements in these two lists and start filling out this new list. And this new list would be sorted. For the moment, just ignore the sorting logic that I'm using. But let us assume that by some magical sorting logic, you were able to sort these two lists and you got the results like. Now, this is the correct answer. You were able to return a new list that is sorted in itself. But what did you do? You occupied 80 kbs of extra space. That is because each node has a size of 10 and this new list has 8 nodes in total. And hence, the total space taken by this algorithm is 50 for the original list plus 30 for the second list and 80 for the new list. So this algorithm takes a total of 160 KB of space. Now let us try to find one more algorithm to solve this problem. Instead of creating a new list, why don't we use the elements of actual list and then create a new list? What do I mean by that? I would take up element number 4 from the list and then I would copy it over to the bottom. Next, I know that the next element is 5, so I take up this element and I copy it at the bottom. The next element would be 8. I take up this and I copy it at the bottom. Going forward, my next element is 15. I take this up and move it over here. Next element is 16. This would come over here. Next element is 20. I take this element over here. And then 23 and then 42. Do you see the difference in both the algorithms? In algorithm number 1, we took a total of 160 KB space. But in algorithm number 2, we did not take any extra space. What we did is we just took up the existing lists and then modified them in some way such that the resultant list is sorted and we did not take any extra space. So for algorithm 2, the space taken by both the lists is still the same. So you can see that algorithm 2 is running in half the space of algorithm 1. And that is certainly a very good achievement. Again, such small kilobytes of data may seem trivial to you. You can think that, oh, I have 8 GB of RAM. Oh, I have 16 GB of RAM. It does not matter to me. But think about a case when you are writing cloud applications. You need to constantly upload and download data. So if your algorithm is taking a lot of memory, that means you are uploading that much data to the cloud and then downloading that much data again. And hence, when your application starts to expand more and more, you would see a considerable latency in your application. And nobody ever likes a slow program. You must have seen those websites where you click and then you forget about it and the page will load in 3 to 4 seconds. And then you lose your attention span and you don't even care about the website so much. You wouldn't want that to happen with your application, right? So what did we learn from all of this? I believe that with these examples, now you have a better clarity of why time and memory are the two criteria to determine the quality of an algorithm. You can certainly go into details of about what is the time complexity and the space complexity, but first it is very essential to understand why these two are the major criteria in determining it. Now, next time you are going for algorithm shopping, you know what to look for. If you liked my content, please do consider subscribing and sharing this video with your friends, as this helps me to make more and more such videos where I can simplify these programming concepts for you. Thank you. Until next time.